Somewhere out there, right now, diamonds are falling from the sky. Not in a story, not in a metaphor. Diamonds, actual crystallized carbon, falling through alien clouds like hail falls here on Earth. It sounds like something a kid would make up. It sounds like science fiction, but it's not. It's one of the strangest, most quietly mind bending facts in modern astronomy, and almost nobody talks about it. So let's talk about it. But first, let's talk about something closer to home. Mercury, Venus, Earth, Mars. These are the planets most of us grew up learning about. Rocky, solid, built from iron, silicon, and stone. Mercury is a scorched, airless ball of rock baking under the sun. Mars is a rust colored desert, dry and frozen, its skies thin and quiet. Earth, somewhere in between, lucky enough to have water, air, and exactly the right temperature for life. These four planets share something in common. If you landed on any of them, you'd have a surface under your feet, a floor, a place where rain, if there is any, eventually lands. Diamonds exist here too on Earth, but only because of an extraordinarily slow, rare process. Deep underground, carbon gets trapped under intense heat and pressure for over 1 billion years before it ever becomes a diamond. Then a volcanic eruption has to carry it up to where humans can actually dig it out. It's rare, it's slow, it's precious, specifically because almost nothing about the process is easy. Now, leave the rocky planets behind. Go further out, past the asteroid belt, past Jupiter and Saturn, the planets most people actually picture when they think big. Keep going to two planets that get almost no attention at all: Uranus and Neptune. They're cold, they're distant. They're often treated like the forgettable ones, the planets you mix up on a test. But underneath their quiet blue surfaces, something is happening that doesn't happen on Mercury or Mars or even Earth. Something almost nobody learns about in school. To understand it, you have to start with what these planets are actually made of. Unlike Mercury or Mars, Uranus and Neptune aren't rocky at all. Scientists call them ice giants. But the ice isn't water ice. Their atmospheres are thick with hydrogen, helium, and something else: methane. That methane is what gives them their strange blue green color. It's also the key ingredient in everything that's about to happen, something that simply isn't possible on the dry, thin atmosphere of Mars or the airless surface of Mercury. Because deep in those atmospheres, conditions exist that don't really happen anywhere else we know of. And it starts with lightning. Not lightning like a summer storm on Earth, lightning on a different scale entirely. The storms inside Uranus and Neptune are some of the most violent electrical events scientists believe exist anywhere in the solar system, far beyond anything Earth's skies ever produce. When that lightning rips through a sky full of methane, it doesn't just light up the clouds, it tears the methane molecules apart. Methane is built from carbon and hydrogen, bonded together. When lightning blasts through it with enough force, that bond breaks. The hydrogen disperses, but the carbon doesn't just disappear, it starts to fall. Now, here's the part that should stop you for a second. Nobody has actually seen this happen. No spacecraft has flown into Neptune's atmosphere and filmed a lightning bolt, splitting methane apart in real time. So, how do scientists know this is happening at all? They built it. In a lab on Earth, researchers recreated the kind of pressure and temperature you'd find deep inside Neptune, then ran an electric shock through a chemical mixture standing in for that alien atmosphere. And carbon, under those exact conditions, didn't just survive, it crystallized into diamond. That single experiment is the reason we believe what's happening up there at all. Not a telescope, not a photograph, a recreated alien storm built by hand in a chamber on Earth, proving in a few seconds what would take Earth's own crust over 1 billion years to do underground. So the carbon falls, but that's only step one. As that carbon sinks deeper into the planet, it doesn't just keep falling through empty sky. The deeper you go inside Uranus or Neptune, the more intense everything becomes. The pressure increases far beyond anything found inside Earth or Mars or Mercury. The temperature climbs into the thousands of degrees, and carbon, under exactly that kind of pressure and heat, does something we actually understand quite well because it's the same basic process that creates diamonds on Earth, just compressed into a planetary scale version of it happening over and over instead of once in a billion years. Which means if the models are right, it isn't just raining diamonds on Neptune. It's been raining diamonds for billions of years. It might be raining diamonds right now. As you're listening to this, while Mars sits silent and dry and Mercury bakes under direct sunlight, neither one capable of producing anything like it. And these aren't small. Based on the pressure involved, some scientists estimate the diamonds forming inside these planets could be far larger than anything ever pulled out of the ground on Earth. Not flecks, not dust, genuine, sizable diamonds falling through a sky no human has ever seen up close. So picture it, a storm of black clouds and violent lightning, and underneath it, instead of rain, a slow, glittering fall of diamonds sinking deeper and deeper into the planet. Which brings us to the question that actually changes everything. Where do they land? If you picture this like rain on Earth, you probably picture them hitting a surface, a ground, a floor, somewhere they collect. The way rain eventually reaches solid soil on Mars or solid rock on Mercury. But Neptune and Uranus may not have a solid surface at all, not the way we think about one. As you go deeper into these planets, the materials don't transition into rock and stone like a rocky planet's crust. Instead, scientists believe the immense heat and pressure could create something almost impossible to picture: an ocean. Not of water, an ocean of liquid carbon, so hot, so compressed, that it behaves like a sea deep inside the planet with no clear bottom and no clear shore. And here's where it goes from strange to almost unbelievable. Some researchers theorize that diamonds falling through that liquid carbon ocean wouldn't simply dissolve or disappear. They might form solid chunks within the liquid, floating there, suspended, diamond icebergs, drifting through an ocean made of compressed carbon, somewhere inside a planet 4 billion kilometers from where you're sitting right now. Nobody has seen this. Nobody can see this. No probe, no telescope, no mission has ever gone deep enough into Uranus or Neptune to confirm it directly. This is built from physics, math, and lab experiments, the closest thing we have to a window into a place we may never actually visit, which means, as far as we know, those diamonds never leave. They don't get mined the way they're mined on Earth. They don't get found. They simply exist forever, drifting in an ocean no human eye will ever see, on a planet no human foot will ever touch. The diamond on someone's hand took millions of years to form on Earth and required someone to physically dig it out of the ground. Out there, diamonds may be forming endlessly, abundantly, and instantly out of reach forever. And here's the part that makes this even bigger than two planets in our own backyard. If this process happens on Uranus and Neptune simply because they have the right ingredients and the right pressure, there's no reason to think it's limited to our solar system. Astronomers have already identified distant exoplanets believed to be unusually rich in carbon, entire worlds that may be built from conditions even more extreme than what we see at home. Some researchers have speculated that certain exoplanets could be, in effect, mostly diamond at their core, not planets with diamonds inside them, the way Earth has diamonds inside it, planets built from diamond. If that's true, then this isn't a rare cosmic accident happening on two quiet, overlooked planets. It might be one of the most common processes in the entire universe. Diamond rain might be falling on worlds we haven't even discovered yet right now. While we go about our lives on a quiet, rocky planet, completely unaware. So the next time someone shows you a diamond and calls it rare, remember this. Rare, maybe, here, on a small rocky world where the process takes 1 billion years and a volcano to finish the job. But somewhere out there, on a cold blue planet with no solid ground at all, diamonds are falling like it's just another Tuesday, and the universe doesn't even notice.